So in our previous lecture, we spoke regarding micellar solubilization, a very important application of surfactant. It is a unique property of surfactant to form micelles, which have a core lipophilic portion where your lipophilic material can dissolve or can be solubilized, and hydrophilic material will get attached onto the micellar surface, getting solubilized into it. This hydrophobic core is when you are dissolving surfactant in polar solvent or aqueous solution. If you are preparing the solution of surfactant in non-polar or organic solvent, then still the micelles will be formed, but those micelles are known as reverse micelles. They are known as reverse micelles because in that case your hydrophobic core is replaced by hydrophilic tails of surfactant. So the common micelles which we get when we dissolve surfactant in water, it is just being reversed. Your hydrophobic core becomes hydrophilic core now, being surfactant dissolved into non-organic or organic solvent. And that's why the micelles which are formed on dissolving surfactant into organic solvents or non-polar solvents are known as reverse micelles. And these micelles helps in dissolving or solubilizing n number of materials into it. So phenomenon where micelles helps in solubilizing the material, that is known as micellar solubilization. Now let us talk about detergency, which is another important application of surfactants. So detergency is another important role or application which is being played by surface active agent. They help in removing the dirt or oily materials from the surface. So detergents, these are the surfactants or the materials that are used for the removal of dirt, and detergency, it is the process where we use detergents for removal of this foreign matter from the surface. Actually, this detergency, this process is said to be complex process because there different steps are being involved while removing the dirt or foreign matter from the surface. So this detergency phenomenon, it involves many action characteristics of surfactants which are being used as detergents. Initially, the wetting of the dirt particle will take place. This wetting needs to be perfect unless and until the wetting of the dirt or the surface which we are going to clean, it is happening properly. We won't be finding that detergency or the removal of dirt will take place properly. And even you must have observed this, that when we go for cleaning of the clothes, we keep it for soaking for some period of time. Even in your washing machine, you must have seen that application. Soaking is first step which is being carried out. So this soaking leads to the initial wetting, because unless and until the interaction between your washing material and the material which is going to be washed, they have proper interaction with each other, the cleaning will not take place properly. So the first step is initial wetting. Then whatever dirt particles or dirt material is there, it will be suspended or emulsified. That suspension or deflocculation of the material, or say emulsification if it is oily or greasy material with the aqueous surfactant solution, that will lead to emulsification or solubilization of the dirt particle. As we have said, when surfactants are being used at concentration which crosses CMC, they form micelles. So if micellar solution is there, the material or oily material or dirt particle, it will get dissolved or solubilized into the core of the micelles. And last step is washing away of the dirt or the particles. Here, sometimes it may happen that when we go for foaming, all these materials which are surfactant or detergents in nature, they have ability of foaming. This foaming leads to entrainment or entrapment of these dirt particles or agent, which helps in removing them or washing away of these materials from the surface of the cloth or the material. So the detergent must possess a combination of these properties. It should decrease the contact angle of your washing vehicle, that is, say for example water, and the material which needs to be washed. Say for example your clothes are there which are being stained. So there has to have a proper interaction taking place between washing liquid or vehicle and the dirt particles. So that role is being properly played by the surfactant by decreasing the contact angle. Then flocculation, deflocculation or emulsification of dirt particle will take place within your washing vehicle, and this happens because of again surfactant property. And last is foaming, which is a property of surfactant which will help in entrapment of the dirt particle, helping us in washing away of dirt materials from the surface of the material or clothes. So it is being said that detergent efficiency, if you want to ascertain, it can be actually ascertained by actually using it and testing its efficiency. Even one detergent material is there which ad has a tagline, "Pehle istemal kare, fir vishwas kare." It is because of this reason only, because efficiency of detergent cannot be just seen, it needs to be tested, and it can be tested by us by seeing whether the washing material is able to clean the stained surfaces or not. Is that clear? Phenomenon of detergency and how surfactant helps in removal of stains or dirt from the surfaces. 3 important steps which are being involved. These are all action characteristics of surfactant which play a role of detergents. 7 to 9 is the HLB scale of or HLB value of surfactant which acts as detergents. Is that clear? Next, we'll be talking about adsorption on the solid surfaces. So in our previous lectures, we kept talking about adsorption at liquid interfaces. Now we need to move on and talk about the adsorption at solid surfaces.